Sorry about the choppy video. It's a never-ending battle with the amount of memory that I can use on this iPad. So, the last problem we're going to look at is initial value problem, y double prime minus 6y prime plus 9y equals 0. Okay, so we go straight to our auxiliary polynomial. Our auxiliary polynomial is r squared minus 6r plus 9 equals 0. So that obviously factors to r minus 3 squared. So r equals 3 has multiplicity 2. Okay, so what does that mean? We have a repeated real root. So that means that our general solution is going to look something like c1 e to the 3x plus c2 x e to x e to the 3x. Okay, so that's because it had it was a root of multiplicity 2. If it was a root of multiplicity 3, then I'd have x squared e to the 3x in addition to these two terms. So to take a look at why that is the case, what I want you to do is I want you to take, and this is just for clarity, it's not to add on to the solution to the problem, compute y prime and y double prime. So y prime is going to be 3c1 e to the 3x. Using the product rule, we'll get 3c2 x e to the 3x plus c2 e to the 3x. For y prime and y double prime, this is what, 9c1 e to the 3x plus product rule again, 9c2 x e to the 3x plus 3c2 e to the 3x plus the derivative of this, which is 3c2 e to the 3x. So combine that all together, you get 9c1 e to the 3x plus 9c2 x e to the 3x plus 6c2 e to the 3x. And that's y double prime. Okay, so if I were to compute 6y prime, what was that, minus 6y prime. So minus 6y prime, what does that end up being? So minus 6 times that's minus 18 c1 e to the 3x. This is minus 18 c2 x e to the 3x. And this is minus 6 c2 e to the 3x. Plus 9y, that's 9c1 e to the 3x plus 9c2 x e to the 3x. So we add this all together, y double prime minus 6y prime plus 9y. What do I get? Well, 9 plus 9 minus 18, that's 0. 9 plus 9 minus 18, that's 0. 6 minus 6, that's 0. So you get y double prime minus 6y prime plus 9y is 0. Okay, and that's just confirmation that the general solution is what I'm claiming it to be, or calling it the general solution to the differential equation. It's the complementary solution. Now, to solve the initial value problem, we're told that y of 0 is 7 and y prime of 0 is 25. We know that the general format is c1 e to the 3x plus c2 x e to the 3x. So if y of 0 is 7, then I can say 7 is equal to c1 e to the 0 plus c2 times 0 e to the 0. So that means c1 is equal to 7. So that's an important piece of information. Using the fact that y prime of 0 is 25, I go to my equation for y prime, and we say 25 is equal to 3c1 e to the 3x plus 3c2 times 0 e to the, I should be plugging in 0 for x everywhere. So that's e to the 0. 3 times c2, 0 e to the 0, plus C2 e to the 0. So we have 25 is equal to 3 times C1. That's 7 plus 0 plus C2. So C2 is equal to 4. And using this information, we can say y is 7 e to the 3x plus 4x e to the 3x. And that is the solution to the differential equation y double prime minus 6y prime plus 9y equals 0. That satisfies y of 0 is 7 and y prime of 0 is 25. All right, so that's the last little bit, the last example I wanted to go through with you. A couple things to note, okay? There are certain differential equations that you should have knee-jerk reactions to, okay? And so if you have something that's of the form y double prime plus a squared y equals 0, that's going to have a complementary solution of cosine ax sine ax, where if it's y double prime minus b squared y, now you're looking at e to the bx and e to the negative bx. So this is a process that hopefully you can see with enough examples underneath your belt. Goes pretty fast. So try not to make more of it than you need to. Remember that as we do these problems, okay, you don't need to make this substitution. Okay, you can just jump straight to our auxiliary polynomial and solve from there. All right, so hope this video finds you well, and good luck.